Thank you, Indrajit. Thanks everybody for joining. Again, wish you a very happy Independence Day. So this session is on reflections on data science, right? And I'm extremely glad and honored to have four very distinguished panelists, right, who are going to take us through an hour of reflections and ruminations in what is going to be, I'm sure, a very engaging conversation, right, and a very insightful one. So I'll hand it over. Well, I'll just introduce Dr. P. Anandan and I'll hand it over to him because he has kindly agreed to be the moderator of the session. Just a sort of note of just a comment to the attendees. We have a live session and please take advantage of this and put in your questions in the Q&A. I'll be curating all the questions and towards the end or as Dr. Anandan feels appropriate, we'll handle them based on our time, right? So with that, let me just briefly introduce Dr. Anandan. Dr. Anandan, for most of us, doesn't really need much introduction. He's a very experienced AI scientist and expert advisor on matters on AI, specifically on ones that are related to social development. He's currently with AI Matters Advisors, and he's been the creator and former CEO of Wadhwan Institute for AI, which is an independent not-for-profit research organization. And he has spent over 30 years in both academia and industry, right? Ranging from being a professor of computer science at Yale University to being a vice president for research at Adobe Systems and Microsoft. And we are really sort of thankful to him for for giving us this opportunity. So over to you, Anandan.
Thanks, Anirban. Also, thanks to Srujana, who has been quite persuasive in getting me and the rest of the panel to do this. I request the other panelists, Dr. Geeta, Dr. Raghu, and Dr. Aditeshwar to turn on their video so we can all see you. The audience can see you. Just about myself, yeah, and many of you would know that I was running Wadhwan Institute for AI until this year. It's, as far as I know, since I left, it's been going very well. I'm really glad to have had the opportunity to do that. But, age catches up with you. So I decided, and also family reasons, I decided to kind of go into semi-retirement and move back to the US, where I live in Seattle now. But my interest in doing things hasn't stopped. So I recently moved into the role of being a consultant or an advisor. And at the moment, working with a few organizations, but I just have to give ourselves a name, AI Matters LLC, AI Matters Advisor. Sounded like a good catchy name. Really, the focus is a lot on social development. So it'll be AI Matters for Development or AIM for Dev. So with that, just introducing myself where I am. But first, let me wish everyone a happy 75th Independence Day. And one of the things I realized that unlike birthdays, you count the first Independence Day at time 0, whereas in birthday, you seem to count it after 1 year. But, very privileged to be able to moderate a panel, at a national event on the 75th Independence Day. And thank you for asking me to do that. I will briefly introduce the three panelists and then go into a conversation. Roughly the format that we are going to follow is I've asked each of the panelists to reflect on one topic or theme that actually they have shown an interest in any case, and then have some Q&A. So we'll go sequentially on 3 topics. So let me first introduce the speakers and ask them to talk about themselves briefly for a minute or so before we launch into it. Dr. Geeta Manjunath, many of you would know her as the founder, CEO, and CTO of Niramai, a distinguished scientist and an entrepreneur. So Geeta, if you want to speak for a minute about yourself, and then I'll introduce the others before we go into the discussion itself. Yeah.
Sure. This is really, really wonderful to be part of this data science discussion on Independence Day, as you said. And then I think it's a privilege also to be part of this panel with wonderful, elite, accomplished researchers and panelists. I'm Geeta, founder and CEO of Niramai, as I'm known now. From a background perspective, I hold a PhD from Indian Institute of Science, and now I guess 30 years into the industry, working on various issues and various problems. A researcher who is more interested in seeing things on the ground, and yes, publishing, but not as much, but really want to see things work. And that's sort of been my main passion. Hewlett Packard Labs, 17 years. And I used to head analytics research for Xerox in India before starting Miramai 5 years ago. Yeah, nice to be on the list.
Thanks, Geeta. Professor Aditeshwar, I'd like to, you are of course a professor of IIT Delhi and has been an important person working in the intersection of technology and social sector for quite a long time. So maybe a couple of words about yourself. Yeah.
Hi, everybody. Good morning and happy Independence Day. It's great to be here. I'm actually, so when Srijana and others reached out to me to be on the panel, I said, I'm not really a data science or AI person, but they said it would be good to have you anyway. So a lot of the work that I've done at IIT, and then I've also actually, more than 10 years back, I also started a social enterprise called Gramvani, which has been working in rural areas towards social development, and we mostly work on communication. So that's what I mean, we've been working on the ground and at the same time also trying to bring some of these reflections into the intersection of technology and social development in terms of what complexities arise, what complications arise when you try to work in environments that typically we're not really familiar with. So I'll talk about some of that. Hopefully, it will be interesting. And just to tell you a little bit about the kind of work we've been doing at Gramvani. So we use voice-based systems on platforms like community radio and interactive voice response. One way to think about it is that we're trying to bring the equivalent of social media, participatory media, to the bottom of the pyramid through voice, because voice becomes that lowest common denominator that even less literate people can easily access. And we do this so people don't need to use the internet. They can interact through regular feature phones. And the kind of use cases that we've seen emerging out of all of this has been very powerful in terms of people being able to share knowledge and information with each other. This is very contextual. They do it in their own language with local references. So it's more easily understandable. So things like question answering in agriculture, career counseling for youth. Then these are two-way platforms which encourage discussion among people. So we've seen some very powerful discussions on like social norms like early marriage, domestic violence. And one of the other strongest impacts have been on social accountability, because this is really about putting the power of technology in people's hands, through which they can express themselves, through which they can talk about problems they're facing with government schemes or inaction on part of government officials. So it really is sort of bringing the power of media and democracy to people's hands. So I'll be happy to talk about those, and hopefully some of it will relate to AI and data science as well.
Yeah, thanks, Adi. Everything relates to AI and data science these days. And Raghu, of course, you are a guru in databases and data science, and you were doing data science before it was a field, and it was called data science. And of course, I remember first meeting you when you joined Microsoft, but maybe a little bit about yourself and what you're up to these days.
Yeah. Thanks, Anandan. By the way, it's great to realize we are now within walking distance of each other. You're in Seattle. I didn't realize you'd come back here. So, I had the good fortune to overlap Anandan for a little time at Microsoft. I came here in 2012. I'm a technical fellow and the CTO for the data platforms here at Microsoft. And prior to that, I was at Yahoo, where I was chief scientist for various parts of the company and ran groups in Yahoo Labs. There, I had the good fortune to work with many amazing people, among them both Srijana and Anirban. And before that, for nearly 20 years, I was a professor at Madison. And when I think back about all the various things I've done, it's the people who keep coming back. And I really feel privileged to have been able to work with so many gifted and nice people. So looking forward to a really nice conversation today.
Yeah, thanks, Raghu. Yeah, so the format we follow is that, I'll ask Geeta to go first, and speak a little bit about, really from an enterprise entrepreneur point of view, what are some of the opportunities in data science relevant to India, not just, how you work on data science that may be serving the needs of the world, but particularly the Indian market, the Indian applications, what's specific. And secondly, of course, what are some of the challenges that you faced in building a data science team, getting into the market, et cetera, in India? If you could reflect on it. I'm going to ask you to, really do it in like 6 or 7 minutes, because I'd like then the others to react a little bit to the same topic. So, if you go over 6 or 7 minutes, I might, wave or raise a flag or something. So, so that, okay, please go ahead, Geeta.
Yeah, cool. So when I think about data science in India, that's sort of a broad topic, right? The first thing that comes to my mind is sort of, how data science has started making benefit to our Indian community, right? Though my heart lies in healthcare nowadays, right? It's really, data science has gone in different implicit forms, in different everyday life activities now, no more are, especially during COVID, people ordering things over online, even my mother, my aunt, all of them are so comfortable ordering from, let's say, Flipkart, or, why don't you get it from here, and so on. So it's become a part of life without them knowing that it's sort of, there's a bunch of, optimization things happening, or, the Olas and Ubers of the world, how they're actually used to it rather than going to the main road and, stopping the autos and going. So it's like one aspect is how it has now become practically feasible to actually start using it for everyday life and making the comfort of the citizens much before. So that's sort of, very, very exciting, and also the huge opportunity that lies. That means it is possible to make an impact using technology on the ground, and it is possible to have this adoption, right, seamlessly. So that's sort of the big picture. Having said that, personally at my end, as some of you may be aware, we are trying to see at Niramai, trying to see how AI and machine learning can help to save lives, right? So though it actually started off with a personal experience of losing many people in my close family to breast cancer, I just turned a researcher into an entrepreneur. So that is when I saw the sort of, differences between a research algorithm to an actual practical, feasible implementation, and what are the challenges here. So one particular thing is exactly how we test our algorithms, right? We actually, of course, Kaggle and other wonderful data sets, we take that and then sort of try to do a lab level testing of how our accuracies can be improved and so on. But actually, when you come out to make this happen prospectively, there are no sort of labels, there are no tags. It's really, this is called prospective testing for healthcare particularly, right? So you're actually sort of making ladies come in, take the test, which is based on AI, and we're going to tell whether she has breast cancer or not. I mean, this is live. So if the AI makes an error, we could be losing a life, or even if it is a false positive, we may be affecting her psychologically. And so this makes us almost right on a very thin line of wire, if you will, right? To make sure that both the sensitivity and specificity, right, or precision, recall, depends on which application, has to be really, really worthwhile to the extent that you as a researcher is willing to take the test and live your life with it, right? So that just enhances the ask from the algorithms, assumptions that we are making about the data that's coming in, and so on and so forth. So that the element of making it work on prospective unlabeled data, and then willing to take the challenge of comparing that with other existing modalities, right? So that is a huge transformation. It's not just us. There are several startups who are doing it, which is very, very exciting for me, because as a technologist at heart, seeing that work, and at Niramai, for example, we have now screened 37,000 women and impacted so many people who wouldn't have known that they had cancer, right? I mean, just that AI is able to make a decision. The other aspect is that with the machine learning fine-tuned algorithms, we are able to do almost 20% better than the doctors, right? Which is crazy, actually. So what it tells me is that there is a huge opportunity to make a difference, and that's one aspect. The second aspect is, of course, we are not trying to sort of replace doctors. So because when you try to sort of make it real, you go to a hospital, the first thing is that, what is this lady who has never done, who's not like a doctor as in medical doctor. So they're coming and saying some AI model, which is sort of, machines trying to say whether it's cancer or not. And also we are trying to use a different modality like thermal imaging. So I've never heard about thermal imaging. How is this going to happen? So a lot of doubt and, apprehension about whether this will work or not, whether this will replace my job. So this aspect you will have to handle. So what happens is when you are trying to weave this into the real life, the things that you'll have to take care is how does it actually weave in? And of course, in some cases, it can dislocate some jobs, right? But then it is also creating some different type of profile, jobs of different profile, and that's always happened. And so this is also something that we see. So this is more like the practical implementation, which is very, very exciting, and the same technology can be used in several things. One is, of course, we've done that for breast cancer. Recently for COVID, working with IISc and ARPAC, we also released something that is just using chest x-rays to say whether there is likely COVID infection or not. And initially it was like we built it and we weren't sure whether it's going to be used. Then it was like I just met a doctor and said, yeah, this is important. So 200 doctors we started serving, and now bingo, like 8,000 plus users and so on and so forth, where we saw how COVID affected the rural areas and how it actually people died because they didn't have an ICU to go to. They didn't actually detect early. So the late detection of the COVID or breast cancer or any other diseases, it's actually taking away so many lives. And AI can come in, machine learning can come in and do this sort of obviously the prediction, classification, and risk prediction, and then actually sort of give the enable right kind of treatment, right kind of intervention much earlier, right? So these aspects, is something that's very, very heartening to see. The second angle, which, I think that has improved over time now on data science for India, if you say, is also the kind of support we are getting. And we have people who really want to take algorithms to the ground, right? Again, to make this happen. So that is one aspect. And also we have support for ecosystem, support from the ecosystem for startups, even the government support for it, and so on and so forth. And then research is very, very important, obviously. And so while we improve the algorithmic, accuracies and so on and so forth, we are moving towards almost like a doctor-less system, like a point of care devices, where just a healthcare worker can actually make this decision. So these kind of point of care devices are getting more practical, more adopted. Last but not the least, just being conscious about the time as well, is the hype around it, right? In India as well. I remember long ago when I was part of the CDAC parallel processing. Of course, my master's also, working on parallel algorithms was really, really the system side. And we were saying, oh, those are application people, right? That kind of aspect has now moved to, if you can call data science as an application, but of course there are algorithms, research and so on. So this is now what is most valued. And today, if there is a hero, it's a data science person, a person working in AI. I mean, there's a lot of hype and so on and so forth, but even, everyone aspires to be a data scientist and so on. So that glamour aspect also has kicked in. I guess it's the S-curve, it will fade out, but that is the other growth, as data science in India is concerned. I mean, there are different aspects of this, but maybe I'll pause here and see if our
Thanks, Geeta, and also thanks for being very crisp. A couple of things popped into my mind, which is really, I want others to comment as well. One of them is really, how do you bring doctors on board with the most of this thing that you do? Ultimately, if they don't support it, you're not going to. And then the other is, what are the particular challenges in doing it in India? and as well as, things related to privacy and so on. But hold the answers for a minute because I want to hear from the other panelists as well. Yeah, we'll have, yeah. Any thoughts, Raghu, Adi, on any of the things Geeta said?
Yeah. So one quick thought, if you look at problems like medicine, cancer research, and applying machine learning, these are universal, not specific to a country or a place. In fact, I remember back in the 80s, early 90s, Olvi Mangasarian, my colleague at Madison, brought SVMs to bear on two classes of problems. One was uniquely American, the authorship of the Federalist Papers, right? Who wrote the disputed 12 papers. The other was applying it to cancer imagery that he got from Wahlberg, basically which patients are more likely to respond to chemotherapy, right? On the other hand, if you don't just think of the problem as a mathematical challenge, if you think about it going end to end, then the problems become very unique to the setting in which you're applying it. At that point, you have to think about whether you're doing this with respect to rural populations in India, or whether you're talking about, urban hospitals in Seattle. And the differences, what becomes interesting, what becomes a challenge that you can perhaps address through prediction, these will vary.
Yeah.
Absolutely. Absolutely. If I may just respond, I think this is a wonderful point. So one of the things that I feel is also that when you talk about, of course, AI in cancer research is very, very absolutely global and 100% on that. When you consider India, because of the difference between the number of patients and the number of doctors, right? So the AI as a pseudo doctor is actually very, very useful in rural areas where doctors are not willing to go, cannot go, and so on and so forth, right? Even in the urban area, what happens is that the very few doctors that exist, one radiologist per 1 lakh population, right? So very few radiologists and very few experts, they're flocked with people, flocked with patients. They actually don't have time to breathe or whatever, like have lunch. So in this case, again, AI can be a wonderful tool, to help improve the productivity and reduce misdiagnosis during all this sort of pressure as well. So India has this sort of
we might seem to have lost Geeta, but let's not slow down. I think, Adi, anyway, I was thinking of asking you to, comment on specifically privacy and ethics and other types of issues related to data science broadly, and medical domain in particularly a sensitive one for that matter. But of course, you can talk about anything, and I thought it'd be great if you have some thoughts and, maybe riff off of where Geeta stopped and, so, yeah.
Yeah, no, absolutely. So actually, the previous point that Raghu brought up, and you also brought up, right, that what's sort of unique to these settings in India, let's say, I think that's really where a lot of the crux of putting technology and making sure it gets used properly, that's really where it arises. Because, so I mean, just as an example, right, we'll wait for Geeta to talk more about it. But for example, it's very different from putting a medical diagnosis AI for a doctor who's like a qualified practitioner. Versus, let's say in rural areas, you're trying to give a similar technology to medical practitioners who are basically private practitioners or even so-called quacks. Now, these are, I mean, quack is sort of more of a derogatory term that's often used, but they do serve a very important function. The thing is that they're not qualified. And they do prescribe like steroids and those sorts of things. So they're sort of infamous for that. But then you need the technology to be designed in a very, very different way. I mean, I don't know. This probably Geeta can talk more about this. But this is essentially what's called the socio-technical interface. That with doctors, you might be expecting that the doctor will just use the AI for as an indicator, but in the other case, you might have to be more rigorous. You might have to put more rigorous checks and balances in what unqualified medical practitioners, how they act upon these recommendations of AI. So, that's pretty much been a lot of the insight with our work at Gramvani also, because so when we built our technology, we said, Oh, Geeta is back. Do you want Geeta to go on?
No, why don't you continue
Okay.
for a bit, and I think, yeah, she'll.
Yeah, so even with Gram, I mean, now the reason why we said we would use interactive voice response kind of systems was so that we could keep it inclusive for people. They didn't need the internet, they didn't need smartphones to access, and so on. So we were sort of driven by that. But as we started working in the field, we realized that that's a very simple way. Actually, the what we might think of the community is actually very heterogeneous. And in fact, we found very early on that there was very uneven usage of the platform. Those who were much better skilled, those who had prior exposure to technology, they were able to use these systems more quickly. Plus, we saw reactions on the ground to the extent of they were excluding others, in the sense that you're not able to record messages properly, you're not able to speak up your problems properly, so why don't you let us do it for you? Right now, that's sort of taking agency away from the people. And as we discovered this, we had to work very hard to try and build these social technical processes around the technology to do it properly. So we had to be very careful in identifying volunteers that we were recruiting from the ground, like in ensuring representativeness, that we have volunteers from different class and caste backgrounds. Gender is still one dimension on which we've not solved the problem, right? Because it's very difficult to reach women, and they're so busy, and it's just very difficult to persuade them to use these kind of platforms. So the problem that we saw was that the inherent social equities were really reproducing themselves, right? And we had to take deliberate action to change some of that. So in the same way, even with volunteers, now I spoke a little bit about how the platforms are used for social accountability. And we've been fortunate that many of people working on the ground with us, they've come from a rights based background, from an activist background, but with many others, we had to mentor them. We had to do that kind of a capacity building so that they're able to take it up in a big way. So, so now how does it relate to data science? I mean, see, at a very high level, I think the point is that in our case, we were working in the social development space, and we've always been starved of resources. We've never had enough money to grow rapidly. We've always been running around this donor, that investor, this and that. And it's an ongoing struggle to basically keep it going in some sense. What I feel a bit scary is somewhat, I mean, I do use AI and data science in our work, but still sort of looking at it from the outside, there's so much of resources being poured into it. I mean, at least in my lifetime, I've not seen that. And from when I started getting into research and everything, I've not seen that kind of money and so much flowing into it. Because if you just scale too quickly before you really know what the social implications of some of these things are going to be, it might just be, so this is called the Collingridge dilemma. So the person David Collingridge, who wrote this fantastic book called The Social Control of Technology, that how can society impose control on technology? And this is like way back in 1980. So the rapidity with which technologies grow. So we've seen examples like Facebook, where again, right, it's been hard. I mean, had it grown slowly, maybe some of these problems could have been anticipated, and they were anticipated. People have been talking about credibility of information for a long time. In my PhD, I did some work on that, but it never sort of caught on until all this mess started happening. Similarly, because with so much money pouring it, there can be all sorts of imperatives can come into picture: corporate, government, even in India, like use of Aadhaar for mandatory use of Aadhaar for like authentication for getting welfare benefits. It's led to a lot of exclusion. And now you can say that, well, was the technology ready, right? Did it have the right processes designed around it? Maybe Aadhaar in itself is fine, maybe, right? But the processes with which different government departments start using it, the way they interface with it, what is their capacity to absorb technology so that it doesn't lead to exclusions, right? Now, a lot of this is dismissed as teething problems, but we just wrote a report recently on how it's not really gone away. Even during the pandemic, there's been so much exclusion. So the government did kindly announce cash transfers and many things, but not many of these things really went through to people, and there was a lot of exclusion. A lot of it was because of either technology failures or failures in like grievance redressal processes that were built around the technology, or in some cases only online mechanisms are provided to people and not, and I mean, you can't expect, right, people who are dependent on Nareka and so on to be able to like go online and file grievances. It's not, so you need that supporting, you need like civil society and so many others to come into the picture. So so I think now data science, of course, the good thing is that, I mean, there's a lot of acknowledgement. I mean, there's so much work going on in fairness of AI and right, but I think all of it needs time to mature. So that's one point. And the good thing is that there's been a lot of experience now also from the civil society, from even academia, and sort of recognizing the kind of issues. The HCI community in general has come up in a big way, step forward to call out many of these issues, and is drawing attention. So I think overall it's sort of moving in a good direction. But I mean, there's much to be done. India doesn't have data protection laws in place, and AI and everything is, I mean, ultimately it is about data, and ultimately the inherent characteristic of the technology is its sort of centralization. I mean, it works better when it's centralized, and that opens up so much of like possibilities of surveillance, behavior control. So there's this fantastic book called Surveillance Capitalism, which talks about many of these things. One other, so I'm sorry for ranting off, but one other point also that I feel is not sufficiently appreciated is that so data science is fundamentally different from, let's say, communication. Communication is pretty much concerned with like transporting bits from here to there, but with data science, you're essentially trying to describe the world in data, right? Informatization, as it's called. And then we manipulate on this data and we try to influence the world. Now, this again has so many, right? If you try to, inscribing natural processes is that we've had, like, I mean, Geeta's work in health, for example, or like in understanding biological systems. I think inscribing natural processes and doing it, we've had a great success. But when it comes to inscribing social processes, that becomes very difficult. Like we've seen issues with criminal recidivism, economic mobility, data-driven policy design. So these are very difficult. We don't know. I mean, social scientists say that it can't be done. Whereas the other perspective is that no, let's inscribe, we'll describe it precisely and accurately. But I mean, these things basically there needs to be a lot of care in adopting these systems. There needs to be regular feedback in figuring out how they're working, not working. It needs to be in a consultative manner, because ultimately you're embedding politics over here. But are our institutions ready so that like these things get reflected in the technology? So I'll stop now. I mean, all.
So Adi, thanks for it. Actually, you covered a broad set of things. I mean, in general, there are many aspects of fairness, of course, security and privacy of information, personal data. But there's one that I want to actually sort of drive the conversation towards, which is kind of both you and Geeta mentioned, which is the safety and utility of the solutions that we, in other words, let's say you do breast cancer or other kind of disease diagnostics using data science. What are the potential risks of them being wrong? But in the context of India, especially, because the current availability of experts is so low, we know that the number of cases of cancer that don't get diagnosed properly, or for that matter, childhood diseases, anything is very high, simply because we just don't have enough qualified doctors. So we almost are working in such a poor prevalence situation. Is it in fact possible that the AI can't do anything any worse than what it is, and it can only do better because of the conditions? Or in fact, are we likely to make it worse by giving these so-called powerful tools in the hands of quacks? I think one of you referred to that. How do you deal with that dilemma? On the one hand, it seems like the opportunity to improve is so large. And again, Raghu would know, in the context of working with the Western US healthcare system, in the Indian conditions, the baselines are so poor. How do you deal with that dilemma?
So,
Geeta, maybe.
Yeah, Geeta.
Sure. So, it's a very valid point. Like we say, right, the tool is, there are both plus and minus aspect, how it is used. Let's say as an entrepreneur or a startup or a company which is providing this to the end users, I think most of the things, including data privacy, doing the right way, and so on and so forth, is all the onus is on the person who is trying to deliver it today, because there are no governance structures in India to sort of, stop these things. Having said that, yes, when we are predicting for cancer, there could be other economic uses of this predicting for cancer, and people, even when we are saying the probability is 40%, they may actually start treating. So all of this overdiagnosis or misuse for commercial benefits are definitely feasible, possible in this in this world in general, not just in India. But so the way we are trying to deal with is, every time we are talking to a customer, because this is a solution we give to the customer, and they have to use it. So whenever we are doing this, we are doing our own sort of due diligence to see, are they ready to do it? But at the end of the day, right, of course, you can have any agreements or something like, any of these, right? So the end user, the integrity of the person delivering this solution using the data science, finally, that is where the misuse aspect can be checked, and it's literally there. But from a legal framework, yeah, even in terms of the data privacy, data usage, data sharing, all of that is covered from a agreement.
The regulatory setup, right? Do we actually have enough of a regulatory background or framework to be able to do these things well in India?
So there is a regulatory framework, but for AI, it is not as good as, let's say, the CE mark, CE or European CE or US FDA, right? Absolutely nowhere there. The reason is whatever it is non-contact, and is assumed to be safe, right? That's sort of not always the case. For example, they say, okay, if the hardware has, is let's say class A, which is non-contact, non-invasive, any software that goes with the hardware is also the same, but it may not be always the case, right? For example, when there is a tool which is unnecessarily calling out with, let's say, low sensitivity, missing out cancers, there is no rule of governance or regulatory body to evaluate the efficacy, whether the performance of the algorithms that are being released is sufficient or not. It really is on the onus of the founder or an entrepreneur, how, whether the model is ready for release or not. This is a crazy thing, because if you consider US FDA, right, something that autonomous, making a decision of yes or no, there are different categories, as 510K, de novo, PMA, like that. So different categories of involvement of the regulatory body is well defined for medical devices in the US FDA. So that's the kind of most stringent, and maybe that kind of stringency is not needed for India. But yeah, I think we should have a body, especially when I talk about medical devices and AI-based autonomous medical devices, we should have a body which will analyze how the study itself was done, how the testing itself was done, how the performance was derived. Like I said, prospective, retrospective, all of these study criteria, and then evaluate whether the device is ready or not. I think there is definitely a scope for a device which is not ready to be released in India. And that is the sort of the negative aspect of it. Like I said, it's completely on the onus of the person, to make a release, whether, I'm okay with a 50% sensitivity or 90% sensitivity. So this is completely, nobody is checking, what exactly is your,
so I'm going to,
they're just checking what they're saying. So that,
thanks, Geeta. I'm going to shift the discussion because I realize where we are on time. One of the topics, of course, all of you have used data scientists, budding data scientists in many cases, to get your work done. And Raghu, who's been not only a practitioner, but also an educator and has both taught many people. And what is your thinking about, how one should go about preparing for doing data science, and how people like Adi and Geeta, and for that matter, you, what do you look for? And I think for the audience, that may be a very interesting thing to think about.
I'll actually go back to the last 5-10 minutes of discussion to ground my answer.
Yeah.
Adi gave, an eloquent description of the work he's doing. and the importance of accessibility of the various techniques we can bring to bear, the various data sets we gather, and how to design the efforts, taking into account a diverse group of people so the right inputs are there. That's one aspect of bringing applied machine learning to bear on problems. He also touched briefly on fair algorithms. So if you apply for a mortgage and you're turned down, and in part it was because some scoring algorithm said you were a bad credit risk, was that algorithm trained on unbiased data? Was the algorithm inherently biased? What is the role of the people, us, who build the software to make those recommendations? In turn, that shifts into who's using these tools we build. We could step back and disclaim responsibility by saying, oh, we're just building tools. That's like a physicist saying, oh, we're just building weapons, right? But when you shift to building atomic weaponry from bows and arrows, I think it's a shift in the level of damage you can cause, or the level of good you can do, that requires us to think very, very hard about how we enable the people who will be using these tools and the people who will be tasked with regulating these tools, how we educate them and on what's really behind all of this, right? So the one thing I would say is education in this area is something we should approach with a very, very broad and thoughtful perspective. Let me give you an example. Should I be able to ask that you share your driving history with me, and in return, I'll give you a better rate for your car insurance? Seems innocuous, right? I mean, what can happen after all? But then take that a step further. Share your DNA with me, and I'll give you a lower insurance rate. Should I be permitted to even go there? I'm not even going to try to resolve that or give you an opinion, okay? But these are the kinds of questions that have way more impact than whether a particular algorithm got a 10% lift in an ROC curve, right? And these are the questions that politicians and judges are tasked with legislating and deciding cases around. What do they know? What do they need to know, right? Likewise, if you take that bank clerk or that doctor, what should they be thinking when they look at the results of a machine learned recommendation, right? If it says this person may be at risk, do a diagnostic test. No big harm if the test is conservative. But if it says this person is free and clear of cancer and they are not, that person could die. So to us, these things seem simple, but how do you give people a frame to understand all of this? At the same time, on a more mundane level, the vast majority of people in this audience and in this field, we make our living by doing things like counting the number of visitors to a website, or by deciding whether a piece of content is spam, or by deciding whether, of the 100 articles at our disposal, which 10 should I show on the front page of Yahoo, right? These are little actions that, when aggregated, make lots of money for portals or our employers. But the consequence of any one of these decisions is so small, there's no human in the loop. We often just deliver the results, make the decisions directly. What are the decisions that it's okay to handle in this cavalier way? When should we mandate that human judgment must sign off? These are hard questions, right? When it comes down to the day-to-day practice of data mining, I want to begin with the word data. I'm a plumber, right? Ultimately, I move bits and bytes around. I make sure they scale. I make sure it's available whenever you need it. And guess what? Without that data, no data mining, no machine learning, goes very far in an enterprise or real setting. So if you want to be a competent data scientist, learn about databases in the broadest sense, right? Wherever the data is, figure out what it's going to take to get it onto your laptop and eventually to deploy it to wherever, right? Be self-sufficient. And along the way, understand all the ways that data can be corrupted. So you can take the steps to make sure it's not, right? Because garbage in, all your fancy algorithms will produce garbage. Very sophisticated garbage, but admittedly garbage. So your data, your input, make sure you understand that first. Second, for all the fancy hype around machine learning, at the end of the day, it's applied statistics. So go learn statistics, okay? That is the one thing I would really absolutely say you need as a building block. Lastly, I'm reminded very much of the time when I was training to become a computer scientist. IIT Madras, my alma mater, had a master's program in computer science, not yet a bachelor's program, right? When I came out, many of the people who were teaching computer science were self-taught. They were converts from machine learning. I mean, from mathematics, okay? Or industrial engineering or electrical engineering. In fact, the computer science department at Wisconsin was a spin-off from numerical analysis, right? I see some of that happening today. The first generation of data scientists, machine learning folks, right? We are specialists, quote unquote, in the tools of this new field. We are saying it requires elements of statistics, your understanding of how those are bundled into algorithms for various common tasks, predictive, classifying, and so on and so forth. You need to learn about data. But as the field solidifies, I really think the next generation of data scientists will just pick up these skills as building blocks, but their true mark will be made deep in a domain. You will not be a data scientist at large, right? Maybe for the first year or two of your career, but ultimately you will be a doctor thinking about design of experiments, interpretation of those experiments, right? Your wet lab and your computer lab will be one and the same. You will be maybe doing astronomy. Already astronomers use machine learning in fundamental ways to classify galaxies. Earlier, I gave you the example of the Federalist Papers, social science, art, pretty much any field will be data-driven and will leverage machine learning, data science. So think about what you're passionate about doing and just be aware that data science will be part and parcel of your basic training, right? So that I think is going to be another shift.
Raghu, actually, you make a couple of interesting points. There was, by the way, in terms of the Q&A, I saw the questions. I'm going to pick up some of them, which I think are worth discussing, and I'm not going to specifically acknowledge the name. So pardon me for that, because we don't have time to do that. One of the questions that came up really somewhat relates to what you said, which is the black box nature of machine learning technologies these days. I mean, everybody thinks that you just like read off the book, the latest deep learning architecture and then get the data on plugin. I mean, the advantage, of course, you can get a lot of things happening, a lot of people doing it. But, going back to what you said, Raghu, which is that, in fact, if you don't understand your domain, plugging in these black boxes may not actually work. And for you both, Adi and Geeta, you must have encountered this challenge. You're trying to hire talent that would solve your problem, but they know how to read the textbook or YouTube video and put the black box. How do you make the transition? I mean, any of you, yeah. How do you get them to do real stuff for your domain as opposed to plugging in black boxes? How do you get there?
Right. So let me start. So I think I completely agree with what Professor Raghu mentioned, right? Person has to have like deep stats, independent, like the math background. Linear algebra is another thing that I would add, right? But when we find people who say they are good in data science, they are almost Java programmers or Python programmers who know the API, who can reel out the parameters of the API you have to call. Because that's not what you can always Google to do a quick reference of how do you call, let's say an SVM or a TensorFlow CNN, whatever modeling, right? But the point is like, do you know what's happening inside? So do you know what API to call, what configuration? So that aspect, right? People think it's just yet another Java program or a Python program. So that sometimes is very, uncomfortable to say the least to me, right? Just reducing it. Having said that, so this actually sort of puts a lot of pressure on our hiring pipeline. The number of candidates we interview to actually pick those, let's say 2 or 3 people is very, very difficult. We tried giving written exam everywhere. They're just sort of focusing more on the API level thing. So I think the person who would definitely fit a data science team which is solving a real life problem should be research oriented, should be willing to learn newer algorithms, should have this habit of reading IKDDD and other conference proceedings, papers to figure out what's the sort of the newest one talked about. Willing to experiment off the job, also some of these to learn on their own. So this learning ability is absolutely critical. Understanding what's happening inside is very, very critical. And then, of course, also needs to have the passion and alignment to the startup's vision, whatever is the application that's going. Yeah. Many times they do give, they do need guidance as to the specifics of how to model, what problem, what question to ask once you have the data, all of this. We can't expect somebody to sort of to know everything. So in these cases, we have a teamwork, we have doctors, on our panel, we discuss with them, explore, and then do this together. But I would rather in my data science team have really deep people who are interested in knowing about the application, going all out to make the accuracy, especially for highly critical decisions, taking that accuracy to the highest level, but sort of know their basics well. So that's what we would, basically look for.
Thanks, Geeta. I'm going to ask Adi, you are training these students as a professor at IIT Delhi. And I agree with Geeta that, certain amount of PhD research mentality is important. But then we live in a time where all the kids who want to go off and do a startup and build a company. How do you get them to really learn the deeper stuff? And what do you do about it? Yeah.
Yeah, well, so actually, the problem is slightly different in the sense that it's very difficult to find good people who in the first place, so especially with the COVID, where the digital industry has gotten so much of attention, it's really dried up the market for talent where you can find people who are able to do good data science, AI for social good. So sort of, aim for social development, what Anandan was saying. And yeah, so I completely agree with what Raghu and Geeta were saying, that ultimately it's about responsibility. It's about the deeper domain expertise you have, the more problems you'll be able to catch across the spectrum, not just in the AI model, but also like upstream, downstream sorts of issues. And it needs that greater awareness of not just the technology, but also the broader implications. But yeah, it's just very difficult because the industry is, so like I was saying earlier, there's so much of money that has gone into AI and everything. So I think if somebody were to map which industries it's going into, I think that also becomes important, because we are not able to find enough people whom we would like to hire. And in the IITs, of course, in terms of education, I think, everybody, there's a lot of focus on unraveling the black box, so to say. And we've also started teaching more courses on ethics and social development. So I think that is helping give everybody a big picture. And in fact, I'm teaching a course this time, and we've opened it up for everybody. Because the class is online, so we've said that anybody can just come and attend. And in fact, I've had a lot of interest from other institutes, from even young software professionals who are now coming to these classes. So I think probably we just need more and more of such things for everybody to get that big picture right.
Okay, we have only a couple of minutes. I really don't want to, delay the whole program. Maybe one last word, from each of you on your optimistic or cautious view about the future of data science, not just education, but application and use and business economy in India. I'll start with you, Raghu, since you've not been more quiet than the others. Yes.
I'm rarely accused of being quiet, but I'll take that. So, I'll begin by echoing something that I saw Sunita type in the chat. If you take all the things that go into an end-to-end successful application of machine learning, I don't think there's going to be very many individuals who can do it all by themselves. And I think as educators, our job is to create the right set of curricula, to train the right cohorts, to think about the different aspects of the problems. And when we eventually become leaders, like Geeta at Niramai, it's our job then to assemble the right mix of talents to make sure all aspects are addressed, right? But then that only brings back the question of what are these different personas we need to train, including the leaders who need to be aware of the bigger picture, right? And I can't say how strongly I feel that it's important we lean into this, because machine learning to me is visible, but just one part of a broader trend. The world is being digitally twinned, okay? Pretty much everything is observable, increasingly will be observed, whether it's a heartbeat or a gene or your activity on a website. And subsequently, that data can and will be used to optimize something of interest. And thereby, privacy as we knew it has changed. What is appropriate? Great good will come of this. Great harm can come of this. Our world now has a dual existence in observed bits. And the implications there's no turning back. So I would say many of the questions about ethics, understanding the math, the statistics, the implications, what the math guarantees and what it cannot, what the assumptions are. You don't need to understand the formulas. You need to understand these implications. And then you need to figure out what that means when we apply these tools in any given setting to any given problem. This is not just for specialists. It's got to be part of the fabric of what we learn. If you don't learn about Ranjit Singh or the Tudor dynasty, that may be okay. You can survive in the modern world without that, much though I love history. But if you don't have a basic understanding of data and what you can do with it and what can be potentially good or bad, we'll be in trouble.
Yeah, I think I better refresh on my history. Geeta and Adi, parting words.
Sure. I think just a quick comment on the chat session. I didn't say that API-based programming is bad. I just said that they should know, they should use it, but they should know what's happening inside. That's it, so that they can make the right call. So in terms of the parting words, I think with all this sort of digitization, use of computers, which is like almost taken for granted now in every field, we have definitely moved away from computing-based computing to data-based computing. And so here we are with volumes of data, really useful data that can change life in different forms. And so in that, the role of machine learning and artificial intelligence will be really very, very critical in changing changing the way people live their lives, more comfortably, more healthily, more happily, hopefully. And again, like Professor Raghu mentioned, right? We need data scientists who are like, jack of all in some sense, right? They know about the application, or at least they like the application. They know about the data, they know about the algorithms, as well as they know how to do this program. So this whole bundle is what we're looking at. And I'm sure that like hundreds of them are viewing this, and you definitely have a huge future in trying to change the way India does things in life, right? So that's sort of important. And there's also a huge number of opportunities, especially in India and the developing world, problems where you have to do more from less. And here data science again can help, and sort of all of you have again a bunch of problems to work on. Whatever is close to you, whatever problem you feel passionate about, just pick it up, and definitely there'll be some data science solution which is the most optimal for it. So and I'm very, very excited about the future.
Thanks. Adi, last word?
Yeah, I mean, so I think we've covered all of these points. But yeah, I think ultimately, we've all acknowledged, right, the world is getting increasingly datafied. So it's important to also understand for everybody that what are some of the things that can go wrong in the process. I mean, simplifications that can happen, because the world is very complex, right? What all are you able to convert to data? Because only then you start working on that data. So I think some of that is important, and the social sciences are, we need to look at a lot of the literature over there for guidance, because they really have been talking about qualitative methods where things that cannot be quantified properly, right? So I won't go into like details, but I think we're going even now there's this whole thrust on computational thinking even at the school level. So I think those are some places to intervene, that right from an early age we start educating on what are we converting to data, are we converting emotions to data, how precisely are we representing these emotions, because that will sort of at least imbibe some kind of a doubt that okay, these things can go wrong. Okay, they're not very precise. So I think if that realization is there, then I think it will automatically translate into more responsibility, people being cognizant of mistakes that can happen, and that can be one way, sort of incorporating this thinking into our right from a very early start into the education.
Thanks, Raghu, Adi, Geeta. I mean, really been a pleasure having this conversation. I'm sure everybody knows that this is not a topic that you can close with one conversation. You can only raise a lot of problems, and we can keep reflecting. That said, it's really good to see people who are active coming in with enthusiasm, and frankly, the quality of audience. I've been working in India recently, continuously increases. I do have a lot of hope that I think, given the strong mathematical education foundation India has, we can do the right thing in terms of educating people the right way and work on the right problems. And with that, let me close. Again, wishing happy Independence Day. Take care all. Bye.
Bye.
Thanks, everybody.
Thank you, Anandan,
Bye.
Srujana, Anirban, Geeta, Adi. It's been a pleasure.
Bye.
Thanks a lot.
Thanks. Thanks.
Great.
I'd like to sort of thank all of you. And